So today I'm going to show a CMO CANopen motion object example using an industrial PC. So I've got this Neousys PCOC515, no fan, little industrial PC, and I'm going to use a Kvaser mini PCIe card. There's a cable. This is a 2-channel card, so there's the cable to 2 channels of CAN. I've got a terminator. ADP-NK adapter kit, comes with a little cable, goes into my Neousys compact with a terminating resistor. So termination at both ends of the CAN network. Of course, you could have, as many up to 127 nodes on one channel and then 127 nodes on another channel. So we're just going to use the CANopen master software to jog this motor. So I'll show you a little bit about CMO, but just wanted to show you that the mini PCI slot fits into the bottom here. There was like 5 screws to take out, and you can install the mini PCI card. I've got a serial port here. I'm using up all the USB ports. One's for a keypad, and others for a mouse. This one's for a serial cable on which I can run CME software to monitor while the master's running. I do have one more port left, so I could use the Copley USB to CAN adapter, but I want to show off this mini PCI in case you run out of USB ports. So let's take a look at, first we'll look at the POC mini PCI. So Coastal was kind enough to install the Kvaser for me. I'm not seeing the one that I have here, but the POC 500 series, and it's a model 515. Anyways, these guys are very capable. Neousys, Advantest, and they're familiar with our industry and our type of applications. So they're a big help. There's the POC 500 right there. I knew it was going to pop up. So you can get it without a fan, of course, and then they do have a fan option, but I haven't had any overheating problems. It's designed for industrial applications, so pretty good. And the Kvaser is the mini PCI Express. This is a two channel. I think we should take a look at the spec sheet here to see some of the details. Of course, it's 1 megabit, has a wide temperature range. You also notice that it's a high speed, so 20,000 messages per second for receiving, and sending still equally high. Some of the older models, or maybe not the version 2, but maybe the version 1, had slower rates, but these things can go wicked fast. I don't see the CAN-FD here, but I'm pretty sure it has that too. Anyways, when we go to get the CMO, we can go to the Copley webpage. Let's say under a Neousys CANopen drive, you can download the CMO software, and then you just install the DLL on. It's like a wrapper around the C++ source code, so you can do C# or VB.NET. Some release notes. Anyways, when you install the CME onto your computer, you get a CMO example folder, and you can see the examples. I'm going to look at a VB.NET example for jog. There's the jog example. There's 10 examples, and Anthony's always writing more, so if you don't see what you want, ask. But basically, the idea for the jog example is you put speed, accel, decel, and then you jog plus or minus. And it's event-driven, object-oriented, so you push the button and it runs a bit of the code. But the code is well documented here. What we're going to do to write the CMO, so you set the node address, and then you create an amplifier object. You can set the debug level to create a log file and create a CANopen object. You can set the bit rate. We're going to change this to Kvaser 0 or Kvaser 1, channel 0 or channel 1. So this is for Copley, channel 1 or channel 2, 0 or 1. You initialize the CANopen network. You hand over the AMP object, a network and a node address, and then you can get some parameters from the drive to fill in the text box. So this is taking some velocity and Excel parameters from the vloop and putting them in the text box to use for a starting point. And then you can display the actual position. There's a timer tick, so it keeps updating the actual position on the display. You can set when you jog, you set the profile for XL, decel, and velocity until you let go of the button. So you have functions like mouse up, mouse down, and then click, and then it's a short program, so you get the basic idea. So again, we've got the motor all tuned up, and the drive's in a CANopen mode, and we turn the power on, and then I just run the VB program, and it pops up the tool. It takes the drive from pre-op and goes into op state, and then it enables the drive. So it's the initialize command. There's an extended initialization, so you can power up, disabled, initialize later. That might be useful if you don't want it to enable as soon as you tell it to move, or as soon as you initialize the drive. So initialize extended could have a bit set for initialize disabled, and then you enable later. Anyways, so I'm just using CME also, over the serial port to the drive serial port. This is the Copley SER USB RJ11 based on the prolific drivers. They were already on the PCOC515 here. It's a Windows operating system. I had them install. And I can monitor with CME, so I can see the actual position and what's going on with the network while I'm running the program from the CANopen master. And I'm just going to simply push the jog button, and it's using the parameters from the drive that were programmed on the vloop screen. Presumably we tuned the mechanical system and tested things out. And this velocity, it's a really big number. It's like 26 million, because that's in terms of counts per rev in units of in the drive it's 0.1 counts, but on the display it's in units of counts per second. And this has like 524,288, 500,000 24288 counts per rev. So that's why this number is so big for maybe 120 RPM. And then, of course, for XL and decel, it's in units of counts per second. And again, very large numbers here. And in the drive, the units are based on like 0.01 counts per second. We have to look in the parameter dictionary in the CANopen manual to confirm the units. That's why the numbers are always so big. And of course, I can jog this thing until I get down to the 0 position. Maybe a few more revs away. Whoop. It's a hard one to hit 0 on. There's also, this is an absolute encoder, so you can use the homing example to do like a calibration type homing, like go to the limit switch, back to the index, okay, make this the 0 position, and then we'll just have to modify the program a little bit to put it into the absolute immediate home mode, but that's something you can do with an absolute encoder. I'm also running the Kvaser CAN King, And this is showing me the messages that are coming. I haven't tried to log with this thing yet. I'm not sure if it's possible. It probably is. We'll have to check with Kvaser for tech support on this. But you can see all the CAN messages, and it's pretty lightly loaded. The other tool shows the number of messages received, so you can get a feel for the rate per second. 136 messages per second. There's not a lot of traffic coming back from the drive. It's pretty minimal here, but these PDOs are all mapped up and being used for the motion control. So the network loading here is really low, so you could easily run with like 40 drives with simple kind of point-to-point moves and coordinated motion. You could probably do 6 axes of tightly synchronized 1 to 10 millisecond update rate for control. I've also installed the drivers for the Kvaser. So the card is on the Windows operating system with the Windows drivers. So you can see the Kvaser cards here. There's two real channels here, channel 0, channel 1, serial number, and there's a couple of virtuals here. But these tools all together, in CMO, of course, you can create a CAN log, just set the debug level to 99, and it creates a log file in the CMO folder. But you could also figure out how to use the Kvaser. Looks like they could track the messages and maybe filter them or something. But well, that's it. Thanks for watching Kvaser Mini PCI Express card on a PCOC515 with Copley CMO CANopen motion objects. Thanks.